Welcome to Third World View. Today we're diving into the future of space exploration with 5 fascinating facts about colonizing the moon. You know, when I look up at the moon, I don't just see a big bright rock in the sky. I see a future home for humanity, a stepping stone to the stars. And believe me, the moon has a lot to offer to those bold enough to dream of living beyond Earth. The moon's surface might look smooth and pristine from Earth, but let me tell you, it's far from it. When you gaze up at the night sky and see that glowing orb, it's easy to imagine it as a serene, untouched place. However, the reality is quite different. The moon's surface is a harsh, rugged environment filled with craters, rocks, and a layer of fine dust that covers everything. This fine, powdery dust is called regolith. It's not just any dust. It's a unique blend of tiny rock fragments, glass beads, and mineral particles. This regolith has been formed over thousands of years by the constant bombardment of meteoroids and the relentless solar wind. Imagine the finest sand you've ever felt, but electrostatically charged due to solar wind. This means that the dust particles can cling to surfaces and even float in the air, making it a persistent nuisance for astronauts and equipment alike. The electrostatic charge is a result of the moon's lack of atmosphere, which allows the solar wind to directly interact with the surface. This regolith gets everywhere, and I mean everywhere. When astronauts walk on the moon, their movements kick up clouds of dust that can settle on their suits, equipment, and even find its way into the lunar module. The fine particles can infiltrate every nook and cranny, making it a constant challenge to keep things clean and operational. It can jam up machinery, wear down spacesuits, and even pose health risks if inhaled. The abrasive nature of the dust can cause significant wear and tear on the joints and seals of spacesuits, reducing their lifespan and effectiveness. Inhaling the fine particles can lead to respiratory issues, similar to the problems caused by inhaling fine dust on Earth. But hey, every challenge is an opportunity, right? The difficulties posed by lunar dust have spurred innovation and creativity among scientists and engineers. They are constantly seeking new ways to tackle the problem, turning what could be a major obstacle into a driving force for technological advancement. Scientists and engineers are hard at work developing technologies to mitigate the challenges posed by lunar dust. They are exploring a variety of solutions, from advanced filtration systems to new materials that can resist the abrasive effects of the dust. These efforts are crucial for the success of future lunar missions and the establishment of a sustainable human presence on the moon. Think specialized filters, dust-resistant materials, and even the possibility of using regolith itself as a building material. By harnessing the properties of lunar dust, we can create structures and tools that are perfectly suited to the moon's environment. This not only reduces the need to transport materials from Earth, but also opens up new possibilities for construction and manufacturing on the lunar surface. After all, we wouldn't want our lunar outpost to become a giant dust bunny, would we? The vision of a clean, organized lunar habitat is within reach, thanks to the ongoing efforts of dedicated scientists and engineers. By overcoming the challenges posed by lunar dust, we can ensure that our future on the moon is not only possible, but also sustainable and comfortable. Now you might be thinking, water on the moon? You're kidding, right? It sounds like something out of a science fiction novel, doesn't it? The moon, our closest celestial neighbor, has always been a source of mystery and wonder. For centuries, humans have gazed up at its silvery surface, dreaming of what secrets it might hold. But water? That's something we never expected. But I'm serious. Recent discoveries have revealed the presence of water ice in the permanently shadowed craters at the moon's poles. These regions, hidden away from the sun's relentless glare, have managed to preserve this precious resource for eons. Imagine the excitement of scientists when they first detected these icy deposits. It was like finding a hidden treasure chest in your own backyard. These craters are like cosmic refrigerators, shielding the ice from the sun's heat for thousands of years. The temperatures in these shadowed regions can plummet to a bone-chilling -250 degrees Fahrenheit, creating the perfect conditions for ice to remain stable. It's a stark contrast to the rest of the moon's surface, which can reach scorching temperatures during the lunar day. And why is this a big deal? Well, water is essential for human life. It's not just about quenching our thirst. Water is a fundamental building block for all known forms of life. It's crucial for drinking, growing food, and even for hygiene. For astronauts, having a local source of water means they can stay on the moon longer without relying on supplies from Earth. And it can also be broken down into hydrogen and oxygen, which can be used as rocket fuel. This process, known as electrolysis, could revolutionize space travel. Imagine being able to refuel spacecraft directly on the moon. It would make missions to Mars and beyond much more feasible. The moon could become a stepping stone for deeper space exploration. Imagine a lunar gas station. This concept, once purely the stuff of dreams, is now within the realm of possibility. A network of lunar bases equipped with fuel stations could support a new era of space exploration. It's a vision of the future where humanity is no longer confined to Earth, but is a multiplanetary species. This discovery has huge implications for the feasibility of long-term lunar habitation. With water readily available, we can build sustainable habitats, grow food, and even produce breathable air. The moon could become a second home for humanity, a place where we can live and work for extended periods. It's like the moon is offering us a cosmic welcome gift. This discovery is a game changer, opening up new possibilities for exploration and settlement. The moon, once thought to be a barren wasteland, is now seen as a land of opportunity. Who knows what other secrets it holds, waiting to be uncovered by future explorers. Transporting massive amounts of building materials to the moon would be, to put it mildly, a logistical nightmare. The sheer cost, the complexity of the missions, and the risks involved in sending such heavy payloads through space are staggering. Each kilogram of material sent to the moon costs thousands of dollars, not to mention the environmental impact of multiple rocket launches. The logistics of space missions are already incredibly complex, and adding the burden of transporting construction materials only compounds the challenges. That's where 3D printing comes in. This cutting-edge technology has the potential to transform the way we approach space construction. By using 3D printers, we can create structures directly on the lunar surface, eliminating the need to transport bulky materials from Earth. This not only reduces costs but also simplifies the entire process, making lunar construction more feasible and efficient. This revolutionary technology allows us to construct structures layer by layer using lunar regolith as the primary building material. Lunar regolith, the loose soil and rock on the moon's surface, is abundant and readily available. By utilizing this material, we can build habitats, research stations, and other essential infrastructure without relying on Earth-based resources. The process involves heating the regolith to high temperatures, melting it, and then extruding it through a nozzle to form solid layers. This method is not only efficient, but also sustainable, as it makes use of the moon's natural resources. Imagine giant 3D printers, like something out of a science fiction movie, churning out lunar habitats, landing pads, and even roads. These massive machines could operate autonomously, working around the clock to build the infrastructure needed for a sustainable human presence on the moon. The possibilities are endless, from creating protective domes to shield astronauts from radiation, to constructing entire lunar bases with living quarters, laboratories, and recreational areas. The vision of a bustling lunar colony built by 3D printers is no longer a distant dream, but a tangible reality within our reach. This technology has the potential to revolutionize lunar construction, making it faster, cheaper, and more sustainable. Traditional construction methods are time-consuming and labor-intensive, but 3D printing offers a streamlined alternative. By automating the building process, we can significantly reduce the time and effort required to construct lunar structures. Additionally, 3D printing minimizes waste, as it uses only the necessary amount of material for each layer. This efficiency is crucial for space missions, where resources are limited and every gram counts. Moreover, the ability to quickly and easily repair or modify structures using 3D printing technology ensures that our lunar habitats can adapt to changing needs and conditions. Plus, it would be pretty cool to say, "My house was 3D printed on the moon." Imagine the sense of pride and accomplishment that comes with living in a home built using advanced technology on another celestial body. This achievement would not only be a testament to human ingenuity and innovation, but also a symbol of our ability to overcome challenges and push the boundaries of exploration. As we continue to develop and refine 3D printing technology, the dream of establishing a permanent human presence on the moon becomes ever more attainable. The future of lunar construction is bright, and 3D printing is leading the way. The moon's lower gravity isn't just great for jumping high. It also makes it a perfect launch pad for deeper space missions. Think about it. Launching a spacecraft from Earth requires overcoming our planet's strong gravitational pull. which takes a tremendous amount of energy. But from the moon, with its weaker gravity, we could launch missions to Mars, Venus, and beyond with significantly less fuel and cost. The moon could become our celestial stepping stone, a gateway to the cosmos. Colonizing the moon is not something any one nation can do alone. It's going to require international cooperation on an unprecedented scale. We're talking about sharing resources, expertise, and a common goal of expanding humanity's reach beyond Earth. Imagine scientists and engineers from all over the world working together, their differences put aside, united by the pursuit of a shared dream. This is the kind of endeavor that can bring humanity together, reminding us that we're all crewmates on this pale blue dot called Earth. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more exciting space content. The future of space exploration is brimming with possibilities, and I, for one, can't wait to see what discoveries await us on the moon and beyond. Remember, the universe is vast and full of wonders, so keep exploring, keep asking questions, and never stop reaching for the stars.